Hey guys, so I realized that I may have missed out on a few things in the previous videos, as well as I wanted to really guide you through your first hurdle, and that's probably the main thing that could off-put you, the Unreal Engine in itself. You see, the first thing you're gonna get a sort of hit with whenever you start making your own game is the control set. And by that, I mean you will literally need to figure out how to make your player move. Now, if you're making something like like a character, like like a biped, like a humanoid, this is not going to be an issue. But if you're making anything different, maybe you want to make a snake or I don't know, whatever, right? Something that does not equate to a to a generic character, you're going to run into some trouble because really there's a lot of ways to define movement in Unreal, and depending on what it is you need, you might have to build everything from scratch on your own. Now, the reason I'm kind of doing this video is because I wanted to cover a few things when it comes to that. I've made over here four player characters, okay? All four of them move in a different fashion. In other words, they can all move. It's just that the systems that govern their movement are a lot more different between each other. I will also demonstrate how you can use components to do whatever it is you need, and I will show you exactly when an interface will come and could have come in very handy. Now I did it by hand. I was just hard coding it, but you will very clearly see when an interface could become very useful in a situation such as this. So first and foremost, we're going to start with the pawn. Now the pawn itself, and here we have, what was the name of it now? I believe it's just worm movement, is it not? I believe, yes, native parent class is a pawn. So here we have the worm that, let's say, I decide to make. Now here, this worm is a fairly simplistic. We're going to check the blueprint out in a little bit. I will simply run the game, and I have this camera set up here so that we could just see what it is we're doing. It's not following the player or anything, so we'll just keep it very simple for now. And if I play, it's gone. I need to kind of pop it off. And as you can see here, I can move from left to right. I can jump, right? I can jump. It's not a very elegant jump, but it gets the job done. And I can backflip, right? That's my backflip. And I've made it so that, let's say this is an actual sort of, let's say this is the player character. We're moving left and right, and there's the ball coming in. You want to smash it. So I made it so that there's a little bit of skill involved. For example, the double jump is only available for half a second. You have to time your double jump. You can't like double jump at the apex of your previous jump. You got to double jump a little bit sooner so that you get to do the spin. And you can change the spin in midair. And of course, you need to have fairly quick hands. But as you can see, it's you can use these. You can use this like sort of a movement component here, which we are going to be looking into right now. But this sort of movement allows for very high, it's a very low entry, but it has a very high skill gap, because the very fact that you can change the rotation mid-rotation allows you to, like in terms of gameplay perspectives, someone could really become the master of this game. And I know this is a very simplistic game, but I do like when my games involve mechanical skill. In my opinion, that is the pinnacle of skill performance, and I do think that a low barrier of entry and a high skill ceiling should be the norm when it comes to controls. And make no mistake, player character control is your main driver for your game's fun factor. Okay, if you have a sluggish character, or things that lock the player in an animation, such as Dark Souls, which has a completely fabricated difficulty curve, which doesn't come from mechanical reflex or twitch reflex or any kind of adaptivity. Instead of just the difficulty of the game simply comes down to trial and error, and when you die a couple of times you'll figure out the pattern and you can move on. But in terms of difficulty, it's in fact a very easy game, because if you have the experience, in other words the knowledge that this particular boss has such and such attack patterns, there really isn't much you need to do in terms of your timing, so that you can perform your counterattacks and just defeat the boss. In general, I'm not a fan of these games, and I would not develop a game like this because I don't like whenever an animation is locking in the movement. In other words, you're completely disabling the input of the player character in order to play the animation out. And of course, the player is going to get punished. Now, I don't know how it worked out. I did, I heard the Dark Souls thing working out, and I tried the first game, which was in my opinion horrible, and then I tried the second game, which was probably the worst port I've ever played in my life. And then of course I've played the third one, which is okay. It's an okay game, but I really don't see the hype. In my opinion, Ninja Gaiden 2 would be a difficult game where it requires really ninja-like reflexes. Like, I've never beaten that game in the most difficult setting, whereas Devil May Cry I've managed to beat on the most difficult setting. So in my opinion, that is the kind of skill. So that I'm telling you this because I think this is as a game developer, everybody needs to have their own philosophy. Now, in your case, you may have a different philosophy, so make sure to incorporate that into your game. Now, clearly, of course, there's some bugs. If I just keep spamming spacebar, I might cheat a double jump here and there, right? Especially if I rotate, I might get a secondary double jump. I'm not sure what the story is, but then again, this is just a proof of concept. It's not a complete controller. Okay, let me just turn this off. Now, by now, if you haven't realized, this is going to be a long video, so you'd be better off maybe pausing this and going to grab a drink or something. I don't know. If you're following along, then I hope you have a second monitor. Now, that being said, let's dive into this sucker and see what he's made of. Now, first of all, you will immediately notice that in terms of, you can ignore this. This is just some debugging code and testing code. Well, blueprint. It's not technically code, but it will get nativized into C++ if you tell it to. So it could become code, right? But I treat blueprints just as I treat code. It's pretty much the same thing, just in my opinion, more readable. I like C#. It's very readable. I don't like C++ because there's just too many colons, semicolons, and it's just, especially with the macros, it becomes a clusterfuck in my opinion in terms of, like, they really need a wrapper for some of that stuff, but whatever. It's a huge engine. Now, with that being said, notice that I only have 2 functions here, and this is going to drive my point home that you need to know where you're going to put your logic. Now, in this case, I have a jump function and a double jump function, and all they do really is they simply add an input vector, which is driven by this floating pawn movement component. Notice that this floating pawn movement component was not created by me. I simply added it, all right? Floating pawn movement, and there it is. This, by the way, as it says, it simply allows you for simple movement by receiving input. Now, every pawn can receive input. Anything from pawn and below, pawn and character, they do read input. So, it's not necessary for you to use the floating pawn movement. This is just one example. And the floating pawn movement actually has some very nice things, such as maximum speed, acceleration, deceleration, the turning boost. For example, if you have a 3D character, in our case, we're just going left and right. It has a nav movement component, it has like a velocity vector. So you can even have like different planar movement. You can constrain to a particular plane. So in our case, we would be working on the Z and X plane, so you wouldn't want to be going in Y. So you constrain that to that plane and continue on that way. And as you can see, it also has some nice events. If you want to activate or deactivate the input of the character, you could actually run some logic off of that. Now, that being said, it does not implement physics. So if you actually float over here, it's going to say floating pawn movement is movement component, blah, blah, blah. Limits on speed and acceleration are provided while gravity is not implemented. Now, that means that if I activate the physics right now, my character is not going to move. In fact, if I just do that right now, where's my there's my worm mesh, which would be presumably the worm that we're talking to. Actually, we should do this over here on the root, I believe. No, we should do this on the mesh. So I'm going to enable physics on the mesh. Here, as you can see, here is my simulate physics, and I will simply enable them, compile, and if I play, nothing is going to happen. I cannot move, I can't jump, and that is because physics kind of overrules the floating pawn movement. In other words, I've created a gravity component on my own, which I've added this. And this is where your composition, really starts to shine, where you can have a component that adds simply gravity, nothing else, and the thing is going to work. As you can see here, I actually need to disable the physics on that thing before I start to move. And as you can see here, I should now pop up. Now, of course, it's a little bit of an issue. You probably need to activate the tick before you start the game, but this is not going to be a problem if you launch. So how is this exactly working? Let's take a look a little bit deeper. So first of all, like I said, we only have very little stuff. You have an add input vector, which is readable by default, and it's being handled by the floating pawn movement component. It also receives a vector for the for the direction of the input. In other words, the jump direction in this case. And if we break this down, it'll only be on the Z, so it's only going to be pointing upwards. And as you can see here, I'm simply setting the actor rotation with a new rotation. Now that being said, there's a lot more stuff going on than just these two functions. They don't just magically do stuff. You need to set them up. So the first thing to do would be presumably to enable gravity for this thing. So I would go ahead and I wrote a gravity component. Now the gravity component is a fairly simple procedure. When you begin to play, all right, in other words, your worm movement is like, in other words, you start the game, but this is only for the actor. Remember, this only fires whenever you spawn whatever it is you're trying to, this thing is attached to. So whenever the actor holding this component begins its play, in other words, it's being created and spawned, you're going to grab the actor components and we will cache them. In other words, I will get the owner and I will get the component by class, and hopefully we'll have a floating pawn movement. That's the idea anyway. So obviously this wouldn't work on anything that does not have a floating pawn movement. And then you would also get the owner and get the arrow component, because I do have an arrow component over here. The reason for that is because simply the mesh itself, as you can see, the pivot point on it is in a position where it's not ideal for me. I could just as easily use it, of course, but I decided to use an arrow because why the hell not? Now, the reason for that is because I simply want the forward vector of this arrow, right? I want to know where it's pointing, and the forward vector for the arrow, as you can see, would be X. And I could say, okay, so, the pivot point is in the middle of our object right here, and, whenever we will look down, we will presumably find ground at some point, right? So as long as you, like if you had a spike attached to your foot, it'll drive itself deeper whenever you're on ground. In other words, you will be ray tracing, and that's what a ray trace is, right? In fact, you're actually seeing this here. Once I play this, this green dot is a ray trace. The red bit is simply the ray trace itself, and whenever it's green, it returns positive. And this square you see there, like the red square at the bottom, that's just the hit result. In other words, it just shows you where it, connected to some kind of geometry. Now that being said, this is not going to work, of course, if whatever it is I'm attaching to does not hold both of these things. And I should most likely have, an is valid function here to see if, these things are valid, right? If they have it. So I should probably check if the owner has this by class. If he doesn't, then, do this. If he doesn't, then do that. And create these things and maybe do the, add them to the component, to the object by code. Like I said, I generally don't really need the arrow. Now, after we do that, we cache the component reference. In other words, over here, I have it like so, and I can actually talk to the component now. And here, I believe, where should we start first? Grab vectors from arrow, maybe not. Set velocity. Enter to stop the players once they hit. See, that's why you want your comments, because I don't exactly remember what I've been doing. So let's go ahead and check out the vector. So I'm going to basically grab the forward vector and the world rotation from the scene component. In other words, whatever owns this thing, right? And I will simply grab a distance. In other words, I use a distance here, which is my simply a float that says how far will this cube trace basically go down. So it's a box trace, how further down it's going to go. The further down it is, the faster I'm going to hit the ground. All right, so I have to kind of implement my own gravity, right? So that's what I'm basically doing. And I actually didn't, is this connected? This is connected, isn't it? Yes, this is connected. So here what I'm doing is essentially multiplying the forward vector by the distance. In other words, I get the vector, it's usually normalized, so it's from 0 to 1. and then you're multiplying this by the distance that you want to go. So if you say 100, it's going to be 1 times 100. In other words, it'll return 100 in the x direction. After that, you would use the world location just to figure out where your start is. So in this case, it's going to be at the transform, in other words, at the origin of the aforementioned arrow over here. Now, like I said before, if I didn't have the arrow and I simply use this, my origin would be on this side. For ground, it doesn't really matter, I suppose, but since the shape is going to be protruding to the left, sometimes you might want to have a centered pivot. So whenever it is you're exporting stuff, and if you think it's going to be a pawn, make sure to cook your bake your pivot in the appropriate position, because that's not possible inside the blueprint editor, although it is possible inside the level editor, like so. As you can see, this is currently centered. I could simply, I believe it was Alt middle mouse button, and I move it, and there it is. Now, if I click on something else and I click back, it's going to be here. But if I decide to maybe move this thing over to the edge again, I could right click and say a pivot over here, pivot, and I can set the pivot to whatever offset it is, right? And I can also snap it around. Like I said, it doesn't really matter. You can center it on selection, though this rarely works for me for some reason, but whatever. Let's return to the gravity component. And here it's just basically a box trace, and that's how I define where I'm going to start and end. It needs, of course, a beginning and an ending because it's a vector. It has a beginning and an ending and a direction. So there's your beginning, which is the origin of the object, and then I simply add 100 or whatever it is I set here to the forward vector, which is x, and I multiply that, and I get whatever value I desire, which is the length of my trace. This will simply create a box and trace downwards. I've hard-coded these. I've hard-coded the size here instead of promoting it to a variable because, like I said, it doesn't really matter. This is just for demonstration purposes. And of course, it's got all these other good stuff, such as hit values. It's going to return your hit, and as you've seen before, you can split it and really get a lot of stuff out of whatever it is you hit. Different components, the traces, beginnings, like loads of stuff. Chances are, if you want to get information on something, you could just use a ray trace and you'll get it. All right, there's just no way you're not. And of course, you got the trace color, the draw time, etc., etc., etc. You can ignore self, which is always a good idea, and the other things such as what kind of objects are you looking through. This is essentially a collision test. As far as I know, that's actually exactly how collision works. It's part of the physics. But anyway, the point is that if we hit something, which would be true, we would reset the stopper. I don't know what that is. Yeah, so if we don't hit anything, that means we're not grounded. If we're not grounded, we will do something, I believe. Oh yeah, so if we're not grounding, we'll be adding on the gravity. As you can see here, for some reason I'm setting the gravity. I don't know why I decided to do that, but as you can see, gravity by default is, well, the real world gravity is 9.80665 or 9.81 if you don't want to be that precise. And you're simply adding this in the negative direction in the world's z axis. In other words, just going downwards. That's what gravity really is. It's simply a constant acceleration downwards. And then, of course, the reset stopper, I really have no idea what it does. It does this only once, and I believe I did that because I kept falling through the floor. Yes, I had some issues with the floor, so I had to create this little function here, which I really have. I don't remember what exactly it does, but I think it just I think it sets your velocity. Yeah, so that's what it does. So it sets your velocity to 0. The reason for that is because I kept having issues if I was going left and right. I'll just fall through the floor. Plus, it adds a little bit of a, it doesn't allow you to, notice that when I fall, I can't change my direction immediately. You know how I stop? I'm not letting go of the actual button. So this was my fix to the issue. Let me just demonstrate this when it doesn't work. So I will simply, remove this and compile and play. And I should be falling through the floor now. As you can see, there it is. I'm just falling through the floor. And I'm not entirely sure why this happens, because it shouldn't. I mean, I do have a ray trace. As you can see, the ray trace is just lagging behind. Probably the tick. It has to do something with the tick. You can actually define your ticks here in the, I believe, this is the gravity component. So in the class settings, class defaults, and you could set the tick to be during physics or pre-physics or post-physics. Probably pre-physics would be better, but I don't know. I believe I've tried all of them. I never really got a good solution, so I just use this as sort of a stopper. So I'm simply setting the velocity to 0. So there must be something that, like I said, I didn't write the actual movement component here, so I have really no idea how it works, and I don't intend to be actually checking out the C++ code inside it. That being said, this is one way to get your movement going. Now, like I said before, you can't really, like if you want to run collision, you might have to do this on your own. Now, because by default, generally speaking, collision is enabled. And I'll show you a situation where you could use it as collision. So if we take a look right now, I believe it should be enabled by default here as well. Let me see. So that's a sphere, and I will simulate the physics on the sphere. And if I play, I should also probably align it because I don't have movement. Yeah, so, you know, collision still works, so it's not a big deal. You could definitely get away with something like that. So this is one implementation. Another situation would be, of course, to use, I believe here I had something else. This is the pawn collision, which I kind of explained. It's kind of redundant, but the pawn collision also allows you to, why does it not want to possess my guy? Let me just enable this here, possess. For some reason, it's not possessing me, so let me just possess this like this. I really don't want to go get the thing. So if I play this, and there it is, we've got collision. And of course, you can keep adding all sorts of different things, such as, I don't know, like, you know, collision, and you got like a box collision maybe, and the box collision has its own sort of parameter set here, as you can see. When it comes to collision presets, there's loads of them. Now, remember that you don't have to simulate the physics in order to have collision enabled. Collision is enabled by default. You have to actually disable it if you don't want it. So in this case, it actually says it's going to overlap all dynamic because it doesn't have an actual physical presence. If the static mesh, and the static mesh component actually blocks all, whereas we'll block all dynamic or something. I changed it to block all. But the box here, because it's a trigger, this is more of a trigger. It's used for overlaps, and as you can see here, you know, it can overlap with everything. I'm going to talk about this physics bit a little bit later at the end of the video because it's a kind of like a longer topic. But as it stands, you can simply add a bunch of stuff and just see what happens. You know, it will. I don't know. Why is it overlapping? Let me just block all. That's not the best solution, but maybe I should lift this guy here and just lift this guy here as well. Make him bigger. But this, I believe, will create a, there we go. So we got something like this going on. So whatever, right? The point is that you could use your, you know, the simple floating pawn movement and just go nuts, all right? And like I said, there's really nothing here that I'm doing. In fact, the event graph is empty, as you can see. Obviously, I can't jump, but I can move from left to right because of this component. Okay, so I'm going to just close this guy, and the gravity component is pretty much done, so there's no need to talk about that. We're going to go back to the worm movement component, which actually the worm movement component is done as well. The movement pawn. Now, we need to talk about the next one, which is, of course, our, where's my pawn gravity movement, is it? I think that's the one. Let me see. Yes, that's the one. Now, this is, of course, not the complete version. In other words, this was kind of just the faster. Like, I didn't want to spend too much time just troubleshooting. I just wanted to prove a point. So if we play this, it's not possessing again. Why is that? Where's my possession? It should possess. Let me just open this guy up and check the possession situation. It is possessing. So maybe something has gone terribly wrong. I'm not sure what the story is, but essentially it's the same situation as the previous one. Here I did some testing by checking some offsets, how they work, but this should generally work out. I'm not really sure why I cannot move like this. Let me see. This should move now. Oh, okay. It's creating some weird things. I think I've changed something. Now this is, of course, a pawn movement with a gravity component. Now the movement component in this case was the bit that I wrote. So I first wrote a gravity component, and then I made a movement component. Now, granted, it's not as robust as the the Epic provided gravity movement component, because at the end of the day, I don't want to actually use it on here for anything. Granted, I could have simply exported. So you could, by the way, share components. You can simply migrate this guy, I believe. So you can just export this. So this is actually very nice because you can export components between projects. You can migrate them, etc., etc. So that's pretty nice that you can do that. So even if I I could have just simply written this here and then used it and exported it for my for the worm game, which I might actually do for the this particular pawn entirely, which is the worm movement, because it moves quite nicely. I do have the gravity. It's a good starting point for whatever I'm going to do. All I have to do is really swap the mesh. Okay, so what I really wanted to say here is that here I have my gravity. For some reason, I cannot move it, which I should. But the main difference is that in the movement component, I'm simply using, now the world offset, it should be working. There's something wrong here. I'm just not sure what it is. The point is that here you'll be using the impulse. There's no such thing as a jump function anymore, although of course you could write this in your movement component. In the movement component, what I've simply done is I've gotten the movement vector, which is whatever it is. I've consumed it. Maybe my speed is too low. It's only 2. Let's try, I don't know, 20, see what happens. My world offset is not firing properly, and oh, I know, that's why. So in my case, because initially I had this guy lying down like this. This is probably what it is, isn't it? Something like this, yeah. So I've simply been going downwards. Again, this all has to do with the pivot, with the pivot of the thing. But as you can see in this case, gravity is actually, I should probably rotate this thing on the other way, because this is kind of yeah, there we go. So there's my gravity, and I can jump. Now, obviously, this is not ideal. The jumping is not real. And as you can see, my pivot is actually in the wrong spot if I decide to do a flip. And if I do this very close to the ground, it might actually create some issues where I just get to fly off violently like this. As you can see, it's completely gone out of the screen. But if I, let's say, create another object and I added the object somewhere here, maybe I could drive it. Of course, in this case, if I had something, such as in this case, the scene, unfortunately, I have not found a way to automatically move the children as well as the parent. In other words, so let me just show you here. If I create an arrow component, and the arrow component is part of the scene, these components, by the way, this scene component is simply a dummy component, so I really don't need it. Notice, by the way, that even though I deleted it, it did not delete the arrow. But essentially, all these components make up this pawn, this actor, okay? Like I said, composition is the way to go when it comes to creating blueprints most of the time. And of course, you could still use inheritance later down the line. But in general, you wanna have components that provide the functionality that you need, allowing you for a more modular approach to the game. Now, that being said, if we go to the viewport, notice that if I grab my worm and if I try to move it, actually, the worm shouldn't be the root. So I need another arrow, or let's just grab a scene like this. So let's just say my scene is my root. Now, by the way, notice that, be aware that the root is actually, so this component, whatever the component at the top, that is the transform for the actor, okay? Because actors, they don't have their own transforms. The top component has a transform, and that is the that's why, by the way, you cannot move it. You can only scale it, because right now this transform is actually in the world. That being said, the arrow itself, if I move it, I will move both of the objects. However, if I set a world offset to the arrow, to the scene itself, I will not be moving the object, which is weird. So the scene does not actually move the children. At least that is my experience. If we play this, I don't think this is even going to work. Actually, it is working. But as you can see, my pivoting rotation is still, my pivot is still at the, at the worm instead of the arrow. But then again, the arrow is a little bit here. So let's just grab the arrow, put it up Well, I would have to rotate the worm as well, but let's just say that I'm very lazy, and that's what I'm going to do. So technically speaking, yes, this is the forward vector for the worm. It's pointing forward, and my arrow should be, you know, in the middle of the guy. If I rotate this, it's not going to do much. Let's say I decide that, you know what, I'm going to say that this is my new scene component. So let's just say that I'm driving this. I believe I'm driving this through the actor. Yeah, so I'm targeting the root component here when I'm doing the movement. And I believe I'm also doing the backflip I'm doing it on the worm. So let's do it on the arrow. In fact, you could do this, instead of doing this on the arrow, I could do it on the actor. So maybe that's a better solution. But let's try this. Let's see what happens. Maybe that's the right way to go, because I did it on the actor and it did not like it. Not at all. So let's try this. Actually, I should probably disconnect the worm as well. So compile, play. Yeah, this is not working. Even though the arrow is at the top, I am getting some errors, which will probably tell me arrow has to have simulate physics. Oh, my bad. I forgot a little bit about that. So let's simulate the physics on this guy. Where's my simulate physics? Oh, crap. It does not have simulate physics. There's that as well. Yeah, so if I want to add the impulse, it's going to be weird. But let's just say that I'm going to use the worm for the impulse. And for the arrow, I will only use the rotation, which really should be all I need. Can I rotate it? No. As you can see, I'm definitely rotating the arrow. But I cannot rotate the worm itself. So there's that. At runtime, you need to actually target what it is you want to rotate. So the worm it is. And unfortunately, I have not found a way to change the you know, the pivot point of this object in the blueprint. Even if I change it over here, it will still not do it. And by the way, let me just show you, let me prove you that this is actually rotating on its own. So if I possess this guy and I try to do stuff and I simply eject afterwards, I'm not sure which way it should be pointing now. I believe I should show, oh god, it's not here. Well, that's balls. Okay, that's whatever. Just trust me on that one, all right? I'm rotating the damn thing. The point is that this is another way of implementing movement. Now, like I said, this is not a very pretty way, but then again, you could have like a physics material here, allowing you to make a lighter object. You could actually, whenever you're simulating this stuff, you could go ahead and say, well, you know, apart from locking the rotation, I want to use the mass. I want to have a really low mass. But then on the impulse as well over here, since this is a physical calculation, you need to have, actually this should be a velocity change in my case, and we should ignore the mass. Should have like a better jump. Okay, maybe, well, maybe not as strong, but like you get the point, right? You get the idea. There's ways to manipulate your movement so that it is as responsive as you may want it. Like I said, it requires a little bit of tinkering, but at the end of the day, you will be able to get it. Now, the movement component here is not very elegant. You might want to, and like in my case, I was just hard coding vectors. Just as you can see, my X is hooked up to the Y, my Z is hooked up to the X, and my Y is hooked up to the Z. So it's just completely backwards at the way, instead of the way it's supposed to be. But that's how it is. I could have used some vector manipulation, trigonometry, but this is just the simplest way of doing it for now. And at the end of the day, you will want to write a couple of physics formulas down. For example, you might want to get the mass of the object or set up a particular mass and multiply it by the acceleration, which the acceleration would be the change of velocity, you know, and you get your velocity from the input vector. So your input vector equals to your you know, velocity at the time of movement, and you can transform this into acceleration because, you know, this happens every tick. In other words, every time you tick, which would be 60 times a frame, sorry, 60 times a second, not a frame, presumably, hopefully. So this means that you could grab and calculate your, you know, the force that's acting upon the object, and then you could work like that. You could have inertia formulas here. So you could really write down a whole simulation in this blueprint, and then whenever you add this movement component, it will also be working, you know, the way you want it to work. So there's that. Okay. What else? Well, there really is nothing else to talk about when it comes to that bit. There's pretty self-explanatory. You're using the physics, so it's less work. Well, define less, of course. In the first case, you have your physics that kind of allow you to control the this kind of stuff. Whereas with the other one, you kind of had to implement physics on your own. You still had collisions. You have collisions in both situations, but in the physics bit, you actually can use physics functions such as adding impulses and explosions and etc. etc. So it's pretty nice the way it works. In fact, here I'm going to talk about the actual collision system because I do think it's important to understand. Some things are not, like some things are mutually exclusive. So if I went into my pawn component and I decided to add a, let's say, simulation, I believe this would be the best for if I use my character. Yeah, this is the last one I wanted to talk about anyway. So let me just close these. And I will use my character movement. Now this is the already done movement component, and we're not going to use it just yet. I simply wanted to go over the player controller and the character controller. So I will open my worm gravity and worm movement. You will notice that both of them have a jump function and a double jump function. Now in both of these cases, I had to actually implement them on my own in order to be sure that they have this function. If I had an interface, they would have had these functions by default, allowing me to drive their movement using the player controller, which I wrote. Now, the player controller by default has some stuff, I think, does it? Or maybe not. But the player controller essentially is where I hold my controlling logic. So whenever you begin to play, I simply get the player pawn and I then store it, and I do the same for your, like if this fails, I get the worm movement component. Okay, so the idea is that I want to get the, like I'm getting the pawn, but I don't know which pawn I'm getting right now. Okay, in this case, I could be either using the worm movement, which was the initial one, like this one, or I could be using this one, which is the gravity movement. So I need to cast to both of them. So if one fails, I cast to the other. Of course, there's many other ways to get it. This is just the one of the simpler ones. At least the one I thought would be easiest to use. Afterwards, of course, I'm setting them up to to have their own reference variables, so that I don't have to cast every single time. You don't really need to do it on a small scale. You could, as far as you're concerned, for a small game, you could cast every frame, which is, it's not the best, but it's usable, if it's not cached. Depends on what kind of resources you're working with. And after that, I have my input axis left, right, which I believe I did not actually go through. So let's do that real quick. Go to project settings, and I go into my input. There should be somewhere input here. Packaging. Maybe I'm in the wrong bit. Am I in the wrong bit? I should be in the... Yes, it's the project settings. Let me just see here. If I write down input, just go to all settings, just search for input. And this is where? Gameplay debugger. Jesus Christ. I can't find the damn movement now. Is that what it is? Oh, there it is. Input. So engine input. And as you can see, I've set up to maps. Now you should recognize this, of course, from the video way back when I went over the, all of these settings here. Granted, I was kind of flying through them, and I don't really know what every setting does here, but the important ones are, of course, the input, because you kind of need the input. The difference, of course, by the input is that you can simply use this, and you call the function, in this case, left, right, and the player can assign any button, and instead of just saying, yeah, whenever you press D, like in this case, if I say press 1, there's my keyboard event, I could assign 1 to something else, which doesn't have to be, by the way, movement. It could be whatever, right? These are action mappings, and these are axis mappings. The axis mappings are made to return stuff, and this is where you would map your joystick, axes and stuff like that. So we could just say joystick axis, I believe. The gamepad, so gamepad left thumbstick, X minus, Y minus. So, you could use all these to enable joystick controls. And because the reason you're doing this only on one axis is because this is really just the X. This is simply the X axis, and you don't need two of them at the same time. This is for going left and right, because presumably this is only one thumbstick or so to speak. So you got scale 1 and scale -1, which of course means that 1 is going this way, -1 is going that way. And it's, it's fairly self-explanatory. And then you have the jump, which is just using a space bar. You can assign, Shift, Control, Alt, Command, all of those if you really want to be specific when it comes to your controls. And of course, you've got different things such as mouse touch, and there's loads and loads and loads and loads and loads of different settings if you want to go for your motion and gamepad controls, etc. But I stick to mouse and keyboard. I think it's the way to go for gaming, at least for the foreseeable future. And just stick with what you know. That being said, this simply allows me to use this axis here to get the axis value, which is between, of course, like in this case, from 1 to -1. I could make it bigger or smaller, by the way, so just be aware of that. But generally speaking, you want to have control over it by, let's say, how fast the character will walk, etc. That's why I'm simply sending the movement to the pawn, and then I'm getting this, adding the scale value to it. Here I'm getting the forward vector of the actor, whichever is the pawn itself. All right, so I don't care what pawn I am with. I'm simply sending the value. Now, of course, I could use this reference over here and send it to the actor, but because every pawn has input, it's going to receive it. It doesn't matter what kind of pawn it is. The reason I'm doing this bit is because I want to sort out my, airborne bits. This is kind of like my backflip logic. This is where the control happens, right? So you're sending and calling stuff off here, and I'm not sure what I intended to do on this side. I was checking something is valid. All right, okay. So that's what it is. This is where you could get in trouble, because currently I have a worm ref and a worm gravity ref, and both of these I need basically the same controller to be workable, to work on both of these. One is the actual gravity implemented, the one that has gravity working for it. In other words, it simulates the physics, and the other one does not. So they need kind of like different functions. Well, not functions, but these are just different targets. And unfortunately, the jump, for example, if I double click it, it's simply a jump. It does not, I believe. Oh yeah, there we go. It has reference, and I will show you what reference does. By the way, I could have solved this issue by using a pass by reference. By the way, just saying. Instead of doing what I've done here, essentially, I'm going to close the project settings. Where is it? So instead of just having these two, I simply could have used pass by reference. This is another example where you could streamline your situation. I was just gung-ho and just did this, brute forced it, but that's not an elegant solution again, because you don't want, like, imagine if I had 10 characters, 10 different control schemes, and I would be just, oh, is this valid? Oh, well, it isn't. Is this valid then? Oh, it isn't. I could just go further down these steps until I just reach somewhere down here. I have no idea what I'm doing at this point. So that whenever you realize that you're looping yourself into executing the same logic in different ways. This is not an elegant solution. There's a better way to do it. So stop and think about it instead of just, twisting your way down into oblivion. Now, that being said, let's just go over this really, really quickly. Now, basically, I'm receiving the input action of a jump, which is just simply spacebar, and I have a condition, which is a Boolean saying, has the character jumped? In this case, if it's true, if the character has jumped, I want to perform a double flip, double jump. In other words, I want to rotate the character, and in this case, if he's not rotating, then I simply want to jump. Now, in the first situation, I want to jump in a particular fashion, and because the pawn controller itself, the pawn movement component, does not actually come loaded with a jump on its own, I have to make the jump myself. And this is where this jump making is being done. And I kind of like to color code my stuff. I did not color code it here, but generally speaking, you would want to color code this. And I don't know why I extended this that much. But anyway, the point is that I simply have a timeline here. And if you double click the timeline, it will open up. And what it is, it's a value from 1 to 0, which is very smoothly interpolated between these 2 points. And I'm getting a good Gaussian type value. Now, it's only going from 1 to 0. Okay, so the reason it's going from 1 to 0, not from 0 to 1, is because, again, I want my character to kind of slow down as they rise in the air. So this will be like your initial boost of power whenever you jump, and then as it goes down, it'll go to 0, and you're going to slow down, and gravity will take over once again. Now, again, of course, if you really want to overcome gravity, which is, again, 9.80665, you need a jump height which is higher than that. So 15, realistically, you'd be getting, half of that will be just canceled out by the gravity. So you need to cancel out the gravity in the first place. Now, that being said, you will then simply grab, some functions here. And in this case, the isValid bit is pointless because I could simply run the jump function by, receiving it by reference. And I will, like I said, we'll talk about the by reference later. But simply think about it that I simply did not need this isValid bit. Well, it's nice to have it, but it's just didn't need it because look, I have the same jump function twice, right? This is pointless. And I'm targeting two different components, that is true, but I could have just as well used an interface and targeted just the jump function on the interface without caring if whatever it is I'm controlling has a jump function or not. So this is a prime example of when an interface would have helped me out. Not to mention that the pass by reference, which, like I said, just wait a little bit and I'll explain the pass by reference. It's a very cool thing, but I kind of want to do this in a function library so that you can really see how it would be shining in most cases. So here we go, and I simply have my jumper, which has some other logic in it, which allows me to basically set some stuff. So in this case, it sets some booleans, whether I've jumped or not, and once I've jumped, it will perform a secondary jump, which will toggle it, and then add a delay, allowing me, so this is the availability of the double jump. That's where I said that, if you want, this is where like you have to time your double jump properly. So midway through your jump, you would need to double jump if you want to perform the flip, etc., etc. And then, of course, you could toggle your secondary jump on and off. So that's basically it. And if I take a look here, my toggle is over here, which uses a gate, allowing me to open it and close it respectively. And over here, of course, first I open it, then I close it again, allowing me not to double jump, right? So it's going to start closed. I will not be able to double jump unless I specifically open it, allowing this logic to enter. And when it's open, it's going to execute a second function here. Sorry, a second, what's its face? Come on then. A second timeline here that will drive another value. Now in this case, this is the double jump, right? So I'm jumping twice, I believe. Am I jumping twice? It's just toggling, and toggling. Oh yeah, so the actual jumping mechanism is the jumping mechanism is actually handled over here. So whenever you can jump, you'd simply activate your sort of double jump sort of situation, which allows you to do it twice. There it is right here. And of course, then there it is right here. Of course, the valid bit, again, I'm repeating the same function twice. And there's loads and loads of wires. But the important thing is that I'm simply sending a rotation plus a vector, right? Not just the rotation. So I have, in this double jump bit here, I've got two of them. First one is a linear, which is simply a rotation because I want a predictable, consistent rotation. Now, it's not going to look the prettiest, but mechanically it will perform. And then I've got something here. There it is. So they're different, of course, in terms of the functionality. This one is much less. The rotation is 360, whereas this is, between 0 and 1, it's normalized. So there's different results, and I believe this was my extra jump. So I would still get my big sort of instant boost, but then it's going to die out pretty quickly once I get to the middle of my, of my timeline. Which the timeline, by the way, as you can see, only executes for 0.4 seconds. So, it's not that big of a deal. I believe it is at 0.4, 0.38 even. It's not even, it is at 0.4. So that's great. But again, the point is that I'm going to get these two values, and then at the event graph, I will simply feed them into my double jump functions, which respectively take the height of the secondary jump, which is again driven by this bit here, multiply it over there by the height jumping strength or whatever, and then the rotation. Now the rotation is an interesting bit because if you didn't have this, remember if you want to set the rotation, for example, in the initial worm movement, I'm going to delete this character here because I want to demonstrate something like this. So over here, if I play, notice that I can't actually backflip. Now this is actually an error. I should probably have something set as a default rotation situation. But in reality, what I want to be able to do is simply be able to backflip in the same direction. As you can see, I'm changing my backflips, right? I'm backflipping forward, and here I'm backflipping backwards. I simply wanted to use the direction of the movement so that you could do, you know, these different flips, right? So you can change your flip midway, midair. In order to do that, you need to actually store the value itself, and that's why I created this maintain rotation direction thing, which simply gets the rotation, and if it's less than 0, then it sets it. Basically, this is essentially a clamp. Maybe I could have used a clamp, but I think you need to store this. If I store this, the clamp does not store it, so you can't actually clamp a value which is not going to be reset. See, the problem in this case is, of course, because I'm doing this on a secondary jump. I believe I'm not sure if I'm clamping this or not, but the point is that the input is actually per tick. In other words, the left-right thing, this is per tick. So whatever I'm setting this, in this case, my left-right movement is going to be set every tick as long as I'm holding it. Meaning that if I let go of the thing, or because it's different, you know, it's not going to be 1 immediately. It's going to be like 0 point whatever. It's going to climb its way up to 1. This means that my rotation is not going to be very good. So that's why I did that. And of course, I multiplied it by the rotation, allowing it to send the direction. Remember, this only outputs -1 or a 1. Therefore, you know, it's not that big of a deal whether you succeed or not. Okay. So that's basically it. And in fact, I could have just used 1 branch. I don't even know why I did the 2-branch thing. But whatever, you know, to each his own. The point is that this is my controller. Now, it's a fairly basic controller. There's really not that much functionality in it. There's simply a jump and a pretty weird and badly situated function stack, allowing me to really this is not a very extendable controller. All right, if I add more characters, this is really going to start being a problem. But for demonstrative purposes, this is actually a great thing because it allows me to talk about passing stuff by reference now. And if I go over here, don't worry, we'll talk about the character as well. But if I go to my temporary and I open up my library, you will quickly see this is actually our initial stuff. So let's say this is the heel. So imagine if this is not a healing function, but something like a calculation function. Let's just say whether this is health, damage, armor, whatever it is, we simply want to add it or subtract it, right? You don't have to know what's coming. So all you have to do is say, well, I need to grab this by reference. And this reference now is going to be my new primary. Notice that it changed into a diamond. The reason for that is because it simply says, well, you don't know what it is. So in my case, let's just say this comes in and I want to set it. Now, what exactly are you going to set? Like, this is going to be health. We don't really have the health. So what are you going to set? You need to set the actual reference. Set by ref variable. This is the function itself. I don't believe this. You can open this. You have to go to the code itself. But this is my whatever this is, health, damage, anything. And I could simply say, well, I want to set this, and let's just say I'm going to add, this is going to be an adding function, okay? Let's just say this is going to be an adding function. There's nothing else is going to be prevalent here, so I'm not going to be creating any fancy stuff or logic. I will say that I will simply add, let's just say a float plus float, and I will simply add the original bit here, and I will increment it by 50, right? So that's what I'm doing, and I'm simply setting this, and I'm continuing my execution, and I could even return the parameter like this because I've already set it here, right? So this is the same thing that I'm passing through. I've set it, and now I can return it. So if I go into, I don't know, the game mode itself, let's say, and I'll begin play, I will call heal, and there's my heal from the library. it will take a new parameter and output a new parameter. But this is essentially my sort of value. Whatever value I have, I can work with. And there it is. There's my value. I'll get that value. This is from before, so it's 250. It's 250 right now. Remember, previously this had to be a heal. If I had something like a heal, I would have to set it, right? In this case, I don't know what I'm coming. It's just any value. This could be health, armor, whatever. As long as this is a float, my function will work. So I'm going to plug this in, and I'll simply print this out. Print. Well, I can actually print text as well. Let's see what happens. Oh, that's the duration. My bad. Yeah, the difference, by the way, the difference between text label, sorry, text name, there's also a name, by the way. I don't know if you're aware. Print name. Is there a name? No. Is there just a name? Yeah. Print string, string, text, and name. They're the same thing, but they're just different in terms of weight. So a name is 8 bytes. A text is 16 bytes. Bits. Right, and of course text is 32 bits. The difference, of course, is that text is localizable. You could, if it's text, you can change, you can translate it on the run, and it will automatically translate everything you say. Whereas strings, they're very set. But the cool thing is you can actually manipulate strings quite well, and the reason they exist as well is so that you don't have too much of a network load, because, well, 8 bits is less than 16 or 32. Now, that being said, let me just output this guy at the end of the day so I just don't end up rambling. So I'm going to output this guy, and I'm going to print this in and begin play. There it is. It says 300. Now, funnily enough, this is pretty much the same setup for incrementing a value. So here I have an increment integer, and as you can see, it's pretty much the same thing. It takes in a value by reference, and it outputs whatever. And as you can see, if I double click this, because this is a macro, it does exactly what I did just now. It sets it by reference, and then it outputs it. So that's one very simple situation. But you should probably, hopefully, this is a for each loop macro, by the way. You should hopefully see, I'm going to delete this, how a passing by reference would have saved me a lot of headache if I simply set this jump value here. I'm currently not sure where it is. And I say, well, I want this just to be a pass by reference. But this is, of course, the vector itself. I cannot actually pass by reference the the object that I'm trying to call this on. So in this case, you would have actually used the interface, and you wouldn't need to get these as valid bits. And the pass by reference would have enabled me to simply send one vector, regardless of what kind of vector it is. But although in this case, I'm still sending one vector. I kind of misled you guys. I'm sorry about that. I forgot that I'm calling the targets themselves instead of passing over a value. But believe it or not, like, passing stuff by reference is not limited to integers, vectors or floats. It's pretty much universal. You can pass by reference anything and work with it as a reference. Though, of course, as whenever you're making the function that you're trying to use, that means that you really don't know what's coming in, so it's kind of more of a logical situation. You really are making more of a macro than a function. But you might come in handy for things like these. Maybe you want to be passing through a particular setup, or simply grab anything. It's kind of like an interface for functions, all right? Passing by reference. Now, that being said, let's finish up with the movements, and I will go ahead and use the last guy in the stack, and that would be my character movement. And there it is, my character movement. As you can see, he's got, something here, and we should most likely simply run this and see what happens. So there's my guy, and I can move him left and right. He can't exactly jump, unfortunately, but that's because my controller is set up very awkwardly. In other words, I'm kind of jumping with, I've set it up to be jumping with 1, because spacebar is currently taken by player controller. So I'm jumping with 1, and as you can see, it has some rudimentary movement, it has some collision, right? So it doesn't have a double jump, but the interesting bit about the character is that for this, I actually don't need any logic at all. I could delete everything here and it would still run. The reason for that is because if I go ahead and take a look at this guy, and I just simply close all these, if I take a look at this guy, he already has a bunch of settings here because this is essentially a character on his own. This is the stuff that you will be using for a 2D character. This is a generic 2D character template, and you have here everything: camera, crouched eye, based eye height, the jump maximum count, the maximum jump count. You can jump 3 times, 5 times, 10 times. Maybe you want to hold your jump, so the longer you hold, the higher you're going to jump. Maybe you want to have some pawn settings here, such as, you know, what kind of controller you're going to use, the pitches. Is it going to replicate or not? What kind of, how it's going to handle input? Is it going to be automatically doing it or not? And you've got loads of other things after that. You've got the capsule stuff, which allows you to get on component hit. So this is basically a pawn, custom pawn, with all the movement component, the gravity enabled. Which, by the way, as far as I know, I haven't dug around the code, but this is also a hack. Right, this is not a true physics simulation. They're kind of hacking this. So, you know, if Epic can do it, so can you. They probably did it better, more optimized. But at the end of the day, what, you know, if you want something, if you want something special, you're gonna have to kind of do this on your own. But this provides a really good starting point for whatever it is you're trying to do, especially for prototyping. This is brilliant. And like I said, it's not limited to bipads. In this case, this mesh, of course, requires a skeletal mesh, but it's not necessary. I simply have a capsule in my situation, which is just there for the ride. Again, if you activate the physics for this, this will create a bit of an issue. I believe it will also... if I go over here and just say, just block all, and if I play this, this should give me an error. Yes, as you can see, I'm simply playing with this thing now, and it's being pushed around by the character. You're not seeing this right now, but it is being pushed around by the character. That is because it's not hooked up properly, and because, you know, that generally speaking, you don't want to be simulating physics on something that kind of has no place simulating physics in the first place. And like I said, the implementation here is not pure physics. You know, the collision, all that is actually handled by code internally. But there's some interesting things. For example, if you create a collision volume, in this case, maybe something like this, just like a box, I suppose. I don't know. Just have a box collision. I think this should return an error right now if I play this. Well, not an error, but a warning. No warnings at all. Why when I get now? Because I'm overlapping all dynamic. Let's just block all and see what happens. And if I do that, let's just move this guy a little bit forward so you can see the thing happening. So there's my thing, and it's moving it, and that's not giving me any issues. That's strange. In some cases, you might have a situation where you are enabling physics, and I think you're gonna run into this trouble with the pawn more than the character themselves. But the pawn itself, you will receive this issue, and that's where you'll have to take a look at your collision presets, and basically it's going to tell you, you know, simulate physics or whatever is incompatible with collision enabled, and you're going to think, well, what the hell am I gonna, you know, how did it happen? You know, what do you mean collision enabled? I want collision. What, are you telling me I can't have collision? The difference is I can't replicate the error here. I don't remember how exactly, you know, what kind of steps you needed to take. But I think it had to be something with a pawn. It had to be something with a pawn and just something there. Basically, whenever you're trying to simulate physics and custom collision or something like that, I think. But the point here is that you will go into your collision presets. Of course, you can play around with your physics material, by the way, on your own. It's a fairly simple thing. It just shows a bunch of bounciness, drag, etc. There's not a lot of settings for physics material, so you kind of... You should kind of figure it out on your own. But over here on the collision presets, you have custom. Of course, you got all these, such as triggers, ragdolls, vehicles. But on the custom bit, you have collision enabled, and you could say currently, of course, it's running query and physics, meaning that you're gonna get hit events. You know, you're gonna basically return collisions, and you will get query events. So you could ask, oh, what did I hit? Oh, what did I overlap? Oh, is this that? Oh, what is that? So you could use that, but in some situations when it throws you the error, it will only be available for one of these two. So whatever it is you're trying to achieve, and it's going to say collision enabled, you know, incompatible with collision enabled. You have to choose whether you want simply, if you only want query or you only want physics. This is basically for performance gains. In other words, it eliminates constant checking. Also, whenever you're setting up your collision responses, I believe you should, like in that case, you really should open the documentation here. That's why it's here, is because collision is fairly interesting, fairly intricately set up. In other words, if an object is blocking something, and another object is blocking that same object, then it will block. But if one object is blocking all, and the other object is not blocking it, I believe it will get blocked as well. So in this case, if the sphere blocked capsules, the capsule blocked spheres, boxes, both of these objects will get blocked by themselves. If one of them does not block it, it will still get blocked. But if it's overlapping, then the overlapping object will go through the block, I believe. Or actually the ignore bit, I'm not sure. I'm not sure. You have to check the documentation for properly, because usually you want to do this once you set up your situation, right? Once you set up your game, you want to just be fairly well aware of kind of channels you have. By the way, you can set up custom channels, some different object responses, right? Not just destructible vehicle physics. If there's something here that you're missing, you can set it up in the project settings. I just don't remember where exactly it was, but it is there. The point is that at the object type, you can set whatever object type you want. So this is the object type that this is being considered. In this case, the box. It will be considered as world static. It could be world dynamic or whatever. And then, of course, you set up if you want something to overlap or not. The overlap will return events and hits. You know, if you say simulation generate hit events, this will return hits and overlaps. It doesn't have to return both as well. You can just disable this by default. But the interesting thing about overlaps is that both of these, let's say this overlapped and this overlapped, only then, like this, for example, is, I believe, block all dynamic. It's considered world dynamic. This is considered world static. But the point is that if you want to receive an update that these guys overlapped, you will actually have to have both of them have an overlap setup. So if I create a sphere collision, right? There's my sphere collision. Now there's my sphere collision and my box collision. If I want them to report that they have actually overlapped together, I need to have overlap set up for spheres and overlap set up here for boxes. Or in both cases, in this case it's overlapping all dynamic, but I can set it to overlap all. And this has to also have overlap all, or set it up over here, you know, for custom overlap. But the point is that only when both of these objects possess the instruction set to be overlapping, only then will an overlap event actually be calculated by physics. And the reason for that is that if it did not happen, then you'd have a massive performance hit, because then you would have to be actually asking this sphere, for example, you know, every 60 times a frame, a second, or 30 times a second, whatever the physics step is on that thing, on Unreal. I'm not sure what the tick rate is for physics, but I believe it's almost the same as the frame, the regular tick as on its own. But the point here is that if you didn't know, like let's say if both of these overlap, okay, it's a simple Boolean, right? If both of these overlap, you can run a check and say, okay, I overlapped with a sphere, and this guy's gonna say, okay, I overlapped with a box. And the opposite. The sphere is gonna say I overlapped with a box, and the box is gonna say I overlapped with a sphere. But if this was not the case, and this didn't have an overlap, and the box had an overlap, and it was just, you would have to check every single time. Oh, am I overlapping with something? Am I overlapping with something? Am I overlapping with something? Because then you don't really know. The only way to know is simply to keep checking. Whereas in this case, you know, okay, so this object is inside my sphere of influence. I have to check, and get all of its data and return an overlap event. In this case, you don't have to. So this is quite saving when it comes to that. Again, there's there's a few different things you could do. For example, in this case, there's a continuous collision detection. So CCD, you could activate this to, like, on fast objects that could sort of skip a couple of frames ahead, or maybe outrun the physics simulation entirely. This would do the trick, but it's fairly intensive. Well, you wouldn't want to have thousands of things running continuous collision detection. But for fast objects such as bullets, arrows, I don't know, catapults, meteorites, stuff like that, maybe you could use it. Only use it if you're experiencing issues with your physics simulation, of course. In other words, or the collision simulation. And again, you can have all these different checkboxes. Just take a look through them. They might fix you up or break you down, like whatever it is. These checkboxes basically exist because somebody had a feature request, most likely, and they've been at it. And you know they're actually, they could be interesting. Like the multi-body overlap, for example, has its own set solution, and the tooltips on those are quite extensive. So you could really figure out what they do on your own. Again. This class here is the most popular one, especially when you begin playing or making a game, because this allows you to have really a player in the game. I mean, as you can see, you have everything that you ever really need. You have your jump situation sorted out. You have your movement left, right, and forward, by the way. In this case, I simply limited this. But you can move left, right, forward, up, and down. You can do all of these things, and you can start developing your game around that movement. It could be a very simple, a generic game, but it's a situational game where you kind of get your feet wet. The important thing to take over here is that yes, the character component is customizable, but it's customizable in code. So if you really want to customize, you're gonna have to dive into the C++. And even though you know the principles of programming by this stage, hopefully, when you dive C++, it'll take you a while to start reading the code on its own. I don't like it a lot, but at least I don't like reading code. Well, in this case, at least C++. I don't mind reading C#, but C++, especially in Unreal, is kind of messy in my opinion, because it's not complicated. It's just all the words are super long to read. There's like a class can be, it could be this long to read. It could take this much of your screen space, and then it could inherit from another class. So there's going to be like another long ass string behind it, and then it's going to have its own access modifiers and all those things. And at the end of the day, you're just going to have this huge wall of text colored differently. But it's nice to dive down and just check it out at some point. And for small little tweaks, it's definitely not something that's going to get you killed. So if you really have a game already set up, all made around the character, and you really need this functionality, you could either dive down into the C++ code and add the functionality yourself, or change it to the desired functionality, or make a character from scratch using the pawn component, which is much more customizable, but again, a lot more barren in terms of features. So yeah, definitely figure out what you're trying to do, where you're going to place your logic. Because remember, if I placed my logic, let's say I just take this player character here. Imagine if all of this was inside, I don't know, the worm movement here. If all of this was there, then if I decide to swap my player character, so in this case I'm using I'm using this guy. But maybe I could use this other guy as well, right? Which would be the gravity guy. It wouldn't really work because this guy doesn't have anything, and all the logic is over here. So I can't really spawn it and control it. Like, you need to figure out where you want to put your stuff, and that's very important, especially when you start making a game, because it's gonna be the foundation of your game. All right, there's gonna be the framework of your game. And this modular approach using components is very powerful because, like I said before, it allows you to scale your game up. All right, it could be something as small as this, and initially your game is not going to look pretty at all. In fact, it could be simply boxes and spheres and capsules and cones and placeholder assets, basically. That's one way, of course, to make a game. You make the logic first, assets later, or like in our case, you make the assets first, and then you make the logic. See, we even have something here with a sphere. Maybe press end to snap it to the ground. But the point is that whichever approach you take, make sure to spread out your logic accordingly. Whether it's in components, in a function library, which is available project wide, in a in like an interface set, or maybe you want like to have different enumerators with all these structures. There's like loads of different ways of figuring out how to actually develop your game. And one last thing, this compartmentalization, this component setup is not unique to actors. Okay, be aware that this is also possible for levels, and by that I mean this is basically level streaming, where you have a level such as this, for example. Let's say this is a level, and then you have another. I'm not going to demonstrate this, but I'm simply going to explain to you the concept behind it, because if you really want to know it out, first of all, you're at a stage where level streaming is simply pointless, assuming, of course, you're a beginner. If not, then I don't know what you're doing here. Like level, basically, I'm going to give you this rundown so you have an idea. I'm not going to go into it again. But the point is that the level streaming is fairly straightforward. You've experienced this before thousands of times in other games. Essentially, you reach a point where there's a trigger which sends a function, says, "Hey, this guy is over here," and then it's going to load another level, or like so, and then it will unload the previous level, while still maintaining this level. So a level would be kind of like a map in a level. And instead of loading everything, imagine you had something huge, like something like that over here. Like there's a lot of geometry, a lot of logic, a lot of functions, a lot of stuff that doesn't need to be in memory. So essentially, you will break it down. You would break it down into the smaller levels. Something like this, for example, that's a little bit too small, of course. But you would do something like this, and then as the player traversed, this is like a linear experience. As the player traversed, you would be closing doors, collapsing caves, blocking roads, or I don't know, exploding bridges, things that will basically say that the player is never going back. Or if he's going back, then you have some kind of corridor which is S-shaped, so the player will not be able to see over here without actually traveling over there, right? So you need to actually create. So if I simply grab this S shape, so this would be something like that, and there would be a wall here. If I just rotate this guy, well, if I simply rotate this guy like that and move him down, so there would be one wall here, and the player will not actually be aware. This is a pretty bad rotation. The player would not be aware because he's not going to have a line of sight, right? If you don't see what's over there behind the wall, you can simply unload it because there's no point. That's how level streaming works. At least when it comes to linear level streaming. Now, of course, there's other things such as world composition, which I'm not very well versed in. I'm not very well versed in anything, to be honest. But that's by virtue of being a small team, or mainly a solo guy, at least for now. But the point is that if you're a small team, or like no matter what, you have to know as much as you can about Unreal, but you shouldn't specialize in anything, because it is a waste of your time to really specialize in stuff. You really want to be able just to do everything yourself. Now, that being said, there's also other options. The world composition, as mentioned before, is kind of like a top-down view of a grid that allows you to, as far as I know, to use a system of loading levels instead of simply having volumes and triggers and saying, oh, this guy's over here, we need to load, and then when he leaves it, we need to unload everything that's not in his vicinity. Because here you can actually say, oh, the player's going to do this. But if this was an open world, you can't really know where the player's going to go. So then you need to use the world composition system, which kind of has its own set of rules and how to load and unload levels, and kind of like a checkerboard pattern. Really, you're always going to have, as far as I know, in that system, you're always going to have a level like this, right? And then as you move, you can have like thousands of grid, like a big ass grid, and more or less, this will move with you. So the moment you get into this level, these other levels will load around you. This is not going to get unloaded. These will get destroyed. At least that's how I understand it. That's, of course, extremely basic and generic, and I don't really think that's how it works. I think it's much more complicated than that. But it's just a start to understand how it works. And one final thing, by the way, about level streaming, if you're really interested in it, it's actually possible to vertically stack your streams. In other words, it doesn't have to be a linear situation where, oh, I'm traveling here, and then I'm going to look over there, and because I can't see behind me, then I'm going to delete this. You could actually have a level inside a level which spans across the level. What I mean is that imagine if you had like a village, and like if all of this was a village, which I know it's hard to believe, but imagine for a second that this is a village here. You could have a level on top of it, which would be streaming in, which would hold the lighting information. So all the lamps, all that jazz would be in its own level. And then you could break it down even further. All the sounds will be on their own level. You could have, a separate level for the sky sphere, right? You could have a separate level for the NPCs, a separate level for the character, a separate level for AI, right? A separate level for the nav manage. There's all sorts of, like, you could go as granular as possible with the level streaming as well. It also allows several different members to work on one super level, because like this would be the overworld where everybody would be working in, and then everybody would be checking out a particular level in the version control. So you could say, right, I'm going to check this out, and the Bob is going to check this out, and I don't know, Alex is going to check this out. So all three of them will be working on, everyone's going to be working on their own level, which will be streamed in the main level, which, let's say, I will be working on, because I'm the grand master, the grand overlord of game development. But the point is that you can see the changes as you sync with their versions, live. And they can actually see, especially if they're working together, let's say this is a stacked terrain, and you can say, well, okay, you're gonna be dealing with the lights and the wind and the fucking special effects and all that, and let's just see how this works with Bob, who's working on the meshes and all that. And then there's the static guy, which is Alex, and he's like, he's trying to figure out where he's gonna put the houses and all that. And then let's say I'm the game designer, the level designer, at least in this situation, and I decide to, right, guys, I know I'm not happy with this, and that. And in the master world, for example, I'm painting some foliage on a terrain, right? So I'm putting trees left and right. I'm trying to figure out where it's the best spot to put trees, and we're all working together to make a level, which, using the streaming technique allows us to not only work together but also modulate, basically spread apart the functions. And the geez, I need to get a new desk. I think I'm just scratching the leather on my chair. Now, that is basically really everything that needs to be said about components, modulation, physics, referencing, movement components, etc., etc., etc. At this point, I really do feel like I've covered everything in terms of just the programming bits. Like, you should have a fairly good ground, on a fairly good ground, just to get launched forward. So really, from this point onwards, you'll probably be getting better results from documentation than watching tutorials, most likely. You should only resort to tutorials whenever you cannot find the stuff in the documentation, which is fairly common. At least in Unreal, I think Unreal's documentation has to be the worst documentation of all. Because it's so inconsistent, it's just ridiculous. That you could find a topic where it's just so detailed, so nicely presented, with like a long example, and then you're not gonna find the answer to your one question. For example, oh, how does this work? Does this do that, right? And does this work like this, or does it work like that? And you're just trying to figure out which of the two ways it does work. And then you're presented with this beginner example, or worse, simply an explanation. Because a lot of the documentation on Unreal simply revolves around, if here's an example, okay? Let's just say, I don't know, math. Just anything math related is going to be ridiculous. So let's go ahead and check. Simply go ahead and check here. Where's my math? It must be somewhere here. Oh, I don't know. Let's just say I want to use a square. Well, no, it's too easy. I can't find the math section here. God damn it! Come on. Where the hell? Oh, there. Oh, I am in the math section. Oh, that's just great. Let's just say that I'm gonna use I don't know, man. Like, whatever. Let's say I want to use something. I don't know, let's say an inverse lerp. Let's say you want to figure out what the hell an inverse lerp is. God damn it, this has a good tooltip. Okay, let's just say something like this. UE4 lerp. Oops, just lerp. So there's the lerp, and as far as I remember, yeah, there it is. That's great, right? That's like, if you have no idea what a linear interpolation is, oh, you're screwed, because it only says, well, there's the input, which says it takes a float, and there's the output, and there's the input B, and there's the alpha, right? What is the alpha used for? Well, clearly, I mean, you could figure it out on the lerp, that the alpha is driving the blend between the A and B, right? At alpha 0.5, it's going to be half of A and half of B, etc., etc. You should probably drive it through some kind of update. But the point is that at the end of the day, you might run into this ridiculous function, and then your answer is going to be presented in this fashion, which basically says the same thing that it says on the freaking over here. So if you try to lerp something, you'll be like, oh gee, that's great. Oh, what does it do? What does it mean A and B? And in this case, of course, the tooltip is good, but if you remember the explanation, the documentation, it's actually a copy paste between the two. So if there's a math function you don't know what it does, for example, in my case, I didn't have no idea what an ease in out did. Ease in, there's f interp ease in and out. Like, why do you need the alpha if you got the exponent? And like, the answer is I believe the tooltip is pretty shitty as well. If I can't even enable it. There it is. Interpolates between A and B, applying an ease out function. What is that function, right? Like, compared to the alpha, right? But there's like others, like f interp, and in most cases you'll be using just the f interp, by the way, interp2, and just use the delta time and then the speed at which it's going to do. Like this, in my case, in my opinion, it's much better than doing the ease in out and just figuring out how the hell it works. Although there's videos on the web that explain that. So like I said before, from this point onward, documentation, Googling, researching is your best bet when it comes to logic. Now, that's it for my introduction here. And I know I've said this 100 times, but now I'm really going to stick with my word. I'm going to go ahead and basically do the same thing, whether I'm going to migrate or, reprogram something, or like recode it or make it into whatever. I'm not sure what I'm going to do exactly, but I'm going to do the same thing in terms of controls in my, in the actual project with a version control and everything. And I will create the beach, which generally is probably better done using a landscape, but in our case, we made this in Maya. That's basically it. So I'm going to do that, and then when I'm done, I will be talking about the animation bit. So before I implement the animation, I'll already have all the movement done. But when it comes to the animation, it's important. It's important to understand it because it's a whole set of systems, right? The animation in Unreal Engine 4 is pretty much as complex, if not more, as the animation system in Maya. So, strap yourselves in for that, guys. But that being said, it's a very nice system to work with. So yeah, I think you'll like it. It's not the worst, and it's pretty cool. In fact, if you really know what you're doing, you don't need Maya to animate stuff. Yeah, well, for now. Okay, that's it, guys. I'll see you next time. I realize this was a long video, but I really wanted to. I had a lot of stuff to talk about. Okay, so bye-bye.